I'm going to talk a little bit about the architecture of the software for Corpus Christi. We're going to start with the server side first. There is a Python-based server that uses the Flask framework for web development servers. Flask describes itself as a micro framework, so it's quite minimal in the terms of the amount of functionality that it provides on its own, and then it facilitates the use of other modules that bring more functionality to the table to make the development process easier. But Flask itself is really quite straightforward. I'm going to look just at a really quick example of a Flask application. And just this little bit of code up here is a full-on Flask app. So obviously we are going to use the Flask package itself, so we've got to import it from the file system. And there's a step where we construct an instance of that Flask application. We're storing in a variable called app. And this right here, just these 3 lines, represents a complete endpoint to the Flask server. So first of all, there's just an ordinary Python function here, just defined with a def called hello world, and it's just returning a string. So far so good. How do we make that something that we can connect to a web browser or other internet client? Well, that's what the job of this decorator is here. If you haven't seen this before, the @ sign indicates to Python that this is a decorator for this underlying hello world function. And essentially what it's going to do is wrap a function around the hello world function in such a fashion as to allow the Flask framework to find this function when a request comes into the web server from or to this particular endpoint. In this case, it's just the / route, so it would be kind of the default route. So if we were connecting to www.example.com / and then nothing else, that would trigger this route handler. These functions in Flask are often called view functions because their job is to return a view back to the client. In our case, it's going to basically just recover some data, send that back over to the application running in the browser, and then that application is going to use that information to display something to the user. But the key thing here basically is just associating a view function, which is an ordinary Python function, with an app.route decorator to say this function should be called in response to this particular route. And we'll see a lot more examples of that in the source code. Notice that in this case, the view function is just returning a string. We can also return JSON. We can return images. Basically, we can return any kind of content type that we want from Flask that satisfies the request that's being made by the client. Of course, one of the main jobs of our application server is going to be to access the database. And we would rather not have to write the database code directly in SQL, so we're going to make use of an object relational mapper. This is something you might be familiar with from 243. If you recall the use of the objection object relational mapper from the JavaScript ecosystem. We're going to use a similar kind of functionality, but it's going to come from the kind of most popular Python-based object relational mapper, which is called SQL Alchemy. And its job, just like all ORMs, is to take a class in our programming language and turn it into something that can be written to the database or read from the database rather than having to deal with all the details of that ourselves. So we're going to look at some examples in the source code, but here's just a simple one from the documentation for SQL Alchemy. You can see that this is referred to as declarative mapping, right? We're not giving a procedure to say, here's how you talk to the database. We're just going to define a class that is going to be mapped back and forth to the relational database by SQL Alchemy. So in this case, the example is a simple user class. We're defining an ordinary Python class called user. In order to get all the goodness of functionality from SQL Alchemy, we're going to derive this from the base class called base, which we got from this declarative base function. You don't need to worry about that, but that's just something that's being imported from SQL Alchemy. And then we've defined the columns here that are going to be in the table associated with this class. So we're going to have an ID and some name columns. You can see that the columns themselves are being declared as instances of this column class, which is, again, something that's being imported from SQL Alchemy. They each get a type, and that's also an identifier that's coming from SQL Alchemy. So this integer class or string class are sort of wrappers around the underlying strings and integers, but they know how to save themselves to the database and how to retrieve themselves. We can also give additional information using keyword arguments. So this primary key argument tells SQL Alchemy that we want to use this ID column as the primary key for this table. Another thing we need to do when we're using SQL Alchemy is to tell it which table in the underlying database is going to be used to store this particular class information. And we use the __ table name identifier to do that. This is kind of in keeping with other uses of this double underscore thing in Python, where it often expresses some kind of sort of fundamental characteristic of the class. So like the __ init function, that's the constructor for a Python class, is similarly named. And we're telling it to use the underlying user table to store this information. In addition to being able to access the database from inside of our view functions in our Flask server, we're going to want to be able to send information to the client and get information from the client. And that's going to usually take the form of JSON objects. So when the client wants to add something to the database, it's going to send a POST request to an endpoint that's going to interpret the payload of that request as a JSON object that has information about the new thing to be created, and it's going to turn around and it's going to call the SQL Alchemy function to store that in the database. And similarly, if the client requests information of, say, existing users, we're going to get a GET request to an endpoint. That's going to cause the Flask server to fish a value out of the database that corresponds to the users, and that's going to have to be converted into JSON to be sent back to the client so that it can do whatever it's going to do with it. In order to facilitate that process, we're going to use kind of the third major component that we're reusing for our server-side software that has the responsibility of doing what's called serialization. So serialization is basically taking some internal in-memory object and turning it into just a string of characters that can be sent across the network. And there's also a corresponding operation called deserialization, and that's doing the opposite of the serialization process, getting a string from across the network and turning it back into an internal object that can be used in the code. And in particular, the package we're going to use, which has the curious name of Marshmallow, I'm not sure exactly why, it does that serialization and deserialization job for Python. So you can see here in this little simple example that they've got in their documentation, what they refer to as the objects that do this serialization and deserialization is a schema. It's kind of an unfortunate name because it really seems to connect more directly with the database world than with the serialization world, but that's what we have. So this artist schema is basically a class that knows how to get a single field that's a string out of the input and convert it into something that can be used inside of Python, or vice versa. And there's another one here as an example called album schema. So presumably the artists make albums, and the album has a title and it has a release date, and then it has the artist that's responsible for that album. And you can see here that in addition to being able to declare fields that are just sort of scalar data types like strings or dates, you can also declare relationships that are nested. So basically what we're saying here is that an album has nested within it an artist. And that's how we capture the relationships, with one-to-many relationships, for example, between the objects that make up our data model and this ability to serialize and deserialize these things. So what we're going to see when we look at the source code is that a typical endpoint is going to be a Flask view function. It's going to have that @app.route decorator associated with it to tell the Flask server which function to call in response to a particular request. It's going to make use of a Marshmallow class to do serialization and deserialization. And once we've gotten the information from the end user, or in the case of the deserialization process, we're probably going to turn around and call some SQL Alchemy function that's going to convert that information into a format that can be stored in the database. Turning now to the source code, let me give you a brief overview of what's in here. First of all, the API is the server side, right? Sometimes I call that server, sometimes I call it API. In this case, it's a RESTful API, so that seemed like an appropriate name. You're familiar probably already with the doc directory that has a bunch of markdown files in it that have documentation about the system. And then the user interface is stored in another directory called UI. And of course, this is a JavaScript view-based user interface, which we'll talk about a little bit later. Some other directories that are out here, there's some continuous integration stuff that's kind of not fleshed out quite yet. There's Ansible is not only a faster than light communication mechanism from Ender's Game, It's also a tool to use for deploying software onto servers, and we use that to deploy Corpus Christi Live to publicly available servers. So we're going to focus a little bit here on the API layer, which is where the server lives. And you can see in here there's some directories that capture various supporting pieces of information. There's some binaries that let you set up your environment and that kind of stuff. There's an Etsy directory that I usually use as kind of a storage dump for things that I want to keep around but don't really want to have them in the project itself. There's some of the vestigial remains of an internationalization directory here that's hopefully going to go away pretty soon. The migrations directory, if you've tried installing the software already, you would have used or seen this migrations directory. That's where SQL Alchemy's companion product that knows how to update the database according to the data model stores its configuration information. Here's the virtual environment that we use for storing a particular version of Python and all the various modules that are needed by Corpus Christi. Here's the env file, the .env file that contains kind of the secrets that you're going to use to spin up the server. So things like your Postgres password and database name and that kind of stuff. Something that you should never push to version control because it's going to reveal secrets that are never going to go away from that repository. And then here's the top level command that we use to kick off all of the execution of everything inside of Corpus Christi. It's actually a remarkably small file. It really just kind of creates the application and starts it up. But it also brings in various other commands that you have that you may have seen already in the documentation or used that allow you to do various things with the Corpus Christi environment. And these are all accessed through the flask command. So the flask command comes with Flask, but it only has built-in things for a few things. It's got a run command that runs the application. It's got a db command that knows how to set up the database a little bit. But all of the other functionality that we've built into kind of the system administration tool comes from these classes that we've defined. So things that relate to our courses module or our events module or our groups module are all custom commands that we've built that are integrated into the Flask command through this simple file. What we want to focus on here in terms of server-side stuff, though, is going to come out of the source subdirectory. So you can see inside of here that there's various packages that correspond to the different modules in the system. So here's where the events code lives, and the groups code, and the people, and the places. They're all grouped together kind of in that same grouping that we saw with the data model. And within each of these directories, there's quite a lot of similarity. So let's take a look at the groups module, and we'll also open up here, let's open up courses as well. So here in courses, first of all, there is a _init file. If you're not familiar with that file, that's what marks out this directory as containing the files necessary to make up a Python package or a Python module. So the very presence of that init file, even if it's empty, does that job. It makes this directory accessible to your Python program as something that you can import. You can also put code in here that's executed at the time that that module is loaded. And in this case, we're using a part of Flask called a blueprint. It's basically a way to create a kind of a separable part of a Flask application. Rather than having everything kind of all under one directory structure, you can create a blueprint, and that sort of gives you a kind of a sub Flask view of the code. So we're creating this courses blueprint with this particular name and the name of the file, and then we bring stuff in from the API to be able to run the endpoints that are associated with this courses module. And you'll find that if I look at the groups one, it's remarkably similar, except it creates a new blueprint called groups. So it's just a way to kind of section off these things, and you can read more about that in the Flask documentation if you're interested. The next thing here that's in most of these directories that correspond to functional modules is the models.py file. So these are all the models, the SQL Alchemy models that correspond to the database tables that are used by the courses module. So when we talked about the database, or maybe you need to go look at that video if you haven't already, you heard that all of the different sections of the data model are grouped into these same kinds of categories. So there's a courses area in the data model on the ERD that has all of the tables that are associated with courses. And the similarly named Python package here that deals with courses is where you find the code that works with that. So in the models class is where we put our SQL Alchemy models. So let me scoot down here to the actual course model. So here's the course model. Again, this is a SQL Alchemy model that knows how to convert from a Python class to a relational database table. You can see that we have the table name that we saw in the SQL Alchemy documentation. It's called courses course. It's a little bit goofy, just to kind of segment the names of the tables into a corresponding grouping. The tables in the courses module all start with the word courses, and in this case the table itself is the course table within the courses. So I just kind of juxtapose those together to keep the tables a little bit organized, even though the naming is a little weird. We have an ID column that's going to be the primary key, as we saw in the SQL Alchemy example. It's an integer. And then we have some other things here. So the name of the course is a column that contains a string. This string types.medium string, let me go look at the declaration of this. I just created a simple kind of a container class that has some sort of standardized string classes in them. Under the hood, that's going to turn into a char or a varchar field in the database. And rather than just have sort of random lengths for strings, I thought, let's just kind of give a typical length for a short string, a medium string, a long string, and a really long string. So that's all that's going on there. And then as we saw here with the primary key, we can give other attributes to these columns. In this case, we're saying that the name column has a nullable attribute set to false, which means that when this is used to create the database table, it's going to be created as a column with a not null constraint on it. And that means basically that we can't insert a course into our database without supplying a course name. And that's going to be enforced not only by the database, but by SQL Alchemy here as well. We've got a description. It's got exactly the same type, except we allow for a little bit longer string. We have a Boolean. We haven't seen those before, that says whether or not this course is active. Again, as in the discussion about the database, we don't want to delete things from the database because we lose information about the history of our use of the software. But we are at times going to want to sort of say, well, this course is no longer offered. So rather than just deleting the course wholesale and all of the data associated with it, we're just going to have a flag here that says, hey, if we're no longer offering this course, let's set this active value to false. And then we just need to write queries in such a way that they filter out the ones that have an active value that's false. And of course, this is a Boolean field, so we're using another predefined SQL Alchemy class that represents Booleans. We say this cannot be null. It's got to be either true or false. And by default, it's going to be true. So we don't have to give a value for this field. What's going to happen behind the scenes is that the SQL generated to create this table is going to have a default equal to true set in it, so that if we don't supply this when we insert a new row into our course table, it'll have that particular value. Now, so far, what we've been doing is defining the columns that make up the table. But of course, in a relational database, we also want to be able to capture the relationships between tables. And that's what the rest of these static properties are doing here. You can see that there's this relationship, which is another predefined function from inside of SQL Alchemy that allows us to make connections between courses and other things in our database. So for example, we know that the system allows us to assign diplomas to people who have completed a certain number of courses, and we want to know which courses are required for diplomas. So we have a relationship here between course and diplomas. So the relationship basically carries the name of the class to which we're related, and then it also indicates this backpopulates keyword tells us that we also have a relationship from the diploma back to the course table. And the name of that relationship is just called courses. So what this means is that on the diploma table, or the diploma class in our SQL Alchemy case, there's going to be a property called courses that when we access it is going to give us back the courses associated with that diploma. And this also is, but from the perspective of the course, it's going to tell us which diplomas are awarded based on completing this course among others. So anytime we have a relationship between tables, we have to define those specifically here in the object relational mapper. And again, if you've got experience with something like objection, you'll recall that when we declared the model classes in objection, we also have to provide a relation information that maps from that class to other classes, and we define that by making a static function inside of the class that has a list of objects that correspond to the related classes. So it's the same kind of an idea going on here in SQL Alchemy, where we provide additional information to say, here's how you find the things that you're related to. The other thing that's going on in this models.py file for each of these different modules is information about serialization and deserialization. We talked about that in the context of the Marshmallow tool. And for each of these, for most of these model classes that are used to talk to the database, we're also probably going to want to serialize and deserialize information about those models. So when the user interface says, hey, I want to add a new course, these are the various values for the columns in that newly created course, we're going to have to be able to send that across the wire. So when the client sends the JSON object that contains that information, here on the server side, we want to be able to verify that that JSON contains the appropriate fields. And we're going to use the Marshmallow schema object or schema class to do that. So right alongside the class that defines the ORM relationship with courses, we're going to have a second class defined that is by convention just called course schema, right? So whatever the ORM class was, in this case course, just tag schema onto it. And rather than inheriting from our base class from SQL Alchemy for this class, we're going to inherit from our base class from Marshmallow, which again, unfortunately is called schema. And there's a little bit of redundancy here in a way, in that we kind of have to redo the various columns that are going to appear in this ORM class, because these are the things that we expect to get from the client when, for example, the user wants to create a new course. And similarly, these are the things that we're going to want to send back to the client when the client requests a list of current courses or the details of a single course. So it's not surprising that that these fields are going to be duplicated. It's a little bit tedious to have to maintain both of these in parallel, but that's kind of the price we pay to have this nice reliable way of mapping from JSON objects and class instances to things that we can transmit across the wire. So you can see these same fields, the ID, the name, the description, whether it's active, the list of diplomas, the images associated with the course. Let's just look at some of these in more detail. So fields.integer, again, we're saying this ID field is a field that's an integer, which we kind of knew from the way we defined it for SQL Alchemy, but the Marshmallow package doesn't know how to introspect that SQL Alchemy class. So we've got to tell it this is going to be an integer. And in order to prevent a clash between the SQL Alchemy integer class and the Marshmallow integer class, we just, rather than importing this directly, we just import this fields object and refer to the different types of fields by referencing the fields. Look at some of the other things we can specify in these fields for Marshmallow. One thing we can say is that this field is required. If we are trying to serialize or deserialize something and we don't have a value for that field, we want to know about it because it would be an invalid field. So oftentimes where we have a database field, let's take the name field, for example, that's not nullable, right? It has to be present in the database. We're also going to say, here's the name field that we're using for Marshmallow. We're going to say this is required. And if it's not present, when we get, say, a request from the client to add a new course, if that field is missing, Marshmallow right away is going to say, hey, sorry, this is not valid. Don't even bother to try to stick it in the database because there's no name field, and it's going to do that for all the other fields. We can also do some validation. So for example, this validation key takes a whole variety of different functions that we can use here. In this case, we're saying this field has to be non-empty, right? It has to have a minimum length of 1 character. That's probably unrealistically short, but it's at least got to have 1. It can't be empty. So not only does it have to be present, it also has to be non-empty. Here for the ID field, we're establishing a really simple constraint here that's saying that it has to be in a range that's 1 or greater, which conforms with the way that database IDs are generated automatically for us. The other thing that's being done here on the ID field is a little odd. We've got a parameter that says dump only. Marshmallow uses as a kind of an abbreviation for serialization and deserializations the words dump and load. So if we actually switch back over here to the documentation for Marshmallow, we can see that serializing objects is referred to as dumping. And remember, serialization is taking an internal memory structure in Python and turning it into a sequence of characters that can be sent over the wire. So we're taking that kind of more complex internal structure for the class and dumping it out onto the wire. So it's called dumping. And the opposite thing, deserializing is the formal way to talk about it, is taking that serialized thing off the wire and turning it into an in-memory object. So we're loading the stuff off of the wire into memory to create a Python class. One of the things that Marshmallow allows you to do is to say, well, this particular field is dump only. Well, why would we want to say that? So what we're saying is, when we're saying dump only, we're saying we're only going to actually pay attention to this field when we're doing the dumping operation, when we're serializing the internal memory structure into something that we can send over the wire. Why would that be? Well, if you think about the ID, when let's say when a client wants to create a new course, the underlying function in the client-side software is going to send across a JSON object that contains all the details of the course. But the client, the user interface application, doesn't know what ID that's going to end up with, because the ID is going to be assigned by the database. So it's going to, because we're just using auto increment ID fields here, the database is going to just take the next ID off of the list, or the next unused ID, and assign it as the ID for this new course. And it's going to send that back to the application client, so it can further manipulate that course or know how to refer to it on the server side. So we want to have that information go back from the server to the client. In other words, we want to be able to have it there when we dump or serialize the object onto the wire. But when we're getting a new course, we don't want to look for it. We don't want to check to see if there's an ID field when we're creating a new course, because we have no way of knowing what ID field to use from the client's perspective. So we call this dump only. Again, we can also use default values here. We can do more subtle kinds of things like excluding subfields and that kind of stuff, which we're not going to go into in detail, but that's also part of designing these Marshmallow classes. We've got, so remember up above we talked about how we have diplomas, and that basically is a list of the diplomas that use this course or that require this course. We saw how that was defined in terms of a relationship between the course class and the diploma class with this relationship function. And we're going to do something similar here when we're talking about transmitting information across the wire. When I request, say, a list of courses from the server, I'm going to also have the opportunity to receive a list of the diplomas associated with that course. So I need to know how to serialize that, or I need to tell Marshmallow how to do that. And I use, again, as we saw briefly in the example of artists and albums in the documentation, this fields.nested, and I say I want to nest within this list some instances of the diploma schema. So if we scooch down just below here, we see here's the diplomas model, the model class for object relational mapping, but it has an associated diploma schema that has this content. And this is what's going to be used by Marshmallow in response to saying we've got nested diplomas within this course. Let's use this schema to decode those when we're loading and to serialize those when we're dumping. And then similarly for images, which can be associated with a course. So we've seen this init file that marks this course's directory out as a module. We've talked through the models file, which usually contains ORM models and associated Marshmallow models. And then the other crucial element of this module is the API file. And here's where we have our API endpoints that are going to be able to respond to requests from the client software. So let's come down here and take a look at, here's create course. So first of all, again, this is just an ordinary Python function, def create course, and it does some stuff, and it's going to do some stuff in the database, and at the end of the day, it's going to send back a JSON response to tell the user interface what course it created. There's some decorators going on here, though. Remember when we saw in the Flask documentation, we saw something like @app.route. Well, we got a little bit of a variation going on here in the sense that this is now, instead of being called @app, which is kind of an application-wide identifier, this is called @courses. And one of the side effects of creating this, remember this blueprint thing that I mentioned briefly, and we have a blueprint called courses here, that basically is supplying us a different namespace within which these @decorators are going to be used. So when we're talking about this courses module, we've not only collected together all of the portions of the data model that are associated with courses, as we saw in the ERD, we've collected together all of the Marshmallow and SQL Alchemy models into this courses module. We're also kind of collecting together all of the API endpoints under this same courses moniker, and that's what we see here in the API file. Instead of this saying @app, which would be across the whole app, we're going to have endpoints that are specific to the courses module. So this courses identifier is doing the same job as @app by just saying basically, hey, here's a route, but it's a route that's kind of restricted to just this particular module. The route function is exactly the same as what we saw before. And what it's telling us here is that here's the URL that is the endpoint for this particular view function, right? When the client software requests something from www.corpuschristi.org/courses, this decorator is going to tell the Flask engine to run this function. Now, one of the things we didn't see before was the various types of methods that can be supported here. And this, of course, relates to the HTTP methods, or what some people refer to as HTTP verbs. So we have get and post and patch and put and delete and all of the other things that we can do in an HTTP setting. And by default, a route decorator is going to assume that it's only going to respond to GET requests. So the example we saw in the documentation didn't have anything other than a slash here and no additional keyword parameters. But if we want to do something other than, or if we want to respond to something other than a GET, we need to list the methods that we want to respond to here in this methods keyword. If we look down here, the next route that's in this file is actually the GET route for courses. It's going to get all of the courses back from the server and send them back to the client when it requests something at the courses endpoint. So if there's a GET request that's received by Flask, it will look for a route that has the appropriate URL and then is configured for a GET. And that's the default. So in this particular case, although we could say methods equals get, like we do up here for post, it's not necessary because that's a default. In some cases, we might want to have the same endpoint respond to both a get and a post. So if we're doing more of a traditional web application that used a lot of forms for submitting data back to the server, usually you want to have a get request to a form that gives you the form itself, and then when the client sends the response back, it sends a post, and it often goes to the same endpoint on the server. That's also supported by Flask, but it's not quite as common in an API view because the different verbs, the different methods mean different things on the server side, so they're going to usually have different view functions associated with them, and that's why we have here a create course function and a read all courses function in response to either a post or a get request to that courses endpoint. Let's look at the get request here. It's a little bit simpler. So when the client wants to get a list of all the courses, it's going to send a get request to /courses, and that's going to cause the Flask engine to run this function because of this decorator. So what's going to happen here? Well, first of all, we want to fetch the list of courses out of the database. So this DB identifier is something that's kind of used across this entire file. It's imported up above. And then the session attribute within that, so DB for database, obviously. And then we've got a session open with our database at this time. It's just kind of a way of kind of grouping together requests. And the interesting part here is the query. Now this is a SQL Alchemy method that knows how to do all sorts of stuff, but the simplest thing that it can do is just retrieve a particular retrieve the rows from a particular table, or one or more rows from the table. What's going on here is because we say the name of the model, right? If I click through this in my IDE, it should take us back to that course model that we looked at before. So SQL Alchemy uses all this configuration information that it knows about this course entity and makes use of that to request the contents of the course table. And in this particular case, instead of fetching just a single entry from that course table, it's going to get all of them. And that's what we want to do here, right? Read all courses without any particular constraints on it, like an ID for a course or something like that. We just want to get all the courses back. So it's as simple as that to fetch things back from SQL Alchemy. Now, what we also want to do, because as we saw before, that when we fetch courses, we're also going to send those diplomas that are associated with those courses. We're going to iterate over the list of or the values that we got back in this result, which is going to be an array of course objects. We're going to iterate over those, and for each of those courses, we're going to grab course.diplomas. So this seemingly innocuous little reference to the diplomas method within the courses class is going to actually cause another access to the database where SQL Alchemy is going to go, okay, I know that course is an ORM type and it has a relationship to diplomas. So the client code here in the server is going to be asking for all the diplomas associated with that particular course. So it's going to go fetch the diplomas back and associate them with this diploma list inside the course class. We're going to do a similar thing with prerequisite courses and other things, but when we're all done here, what we want to do is send back the list of courses with the associated prerequisites. So what we're going to do is return from this view function the information that we want to send back to the client. In this particular case, we want to send a JSON object that includes all the details of the courses, their prerequisites, and their diplomas as a JSON object. So at this point, this with prereqs is a Python object that has information about all that stuff. What we want to do is serialize that out in a way that's going to allow us to send JSON back to the client, so the client code can pick that up and use it to display the courses to the user. And this function JSONify is a standard Python method that we've imported up above that takes this object and turns it into JSON. And whatever is returned by the view function, in this case read all courses, is going to be what's sent back as a response to this request for courses. So that's what sends all that information back out. So with that knowledge, let's take a look at this other endpoint that's creating new courses. So we're assuming that when the client software called this endpoint, this /courses, with a post request, that the payload of the HTTP request includes a JSON encoded object that has all the fields necessary for creating a new course. So the first thing we want to do is kind of vet that or apply some business logic and make sure that the information we're receiving from the client is in the right condition. So one of the things we're doing here, I'm really not sure where this came from. If the active flag is not in that request, we're going to turn it on. So this is just a kind of a little patch here to make sure that when we're creating a new course, it gets activated. I'm not exactly sure why that's there. But the interesting part here is that what we want to do is use our Marshmallow schema to verify that we have all of the necessary information to successfully add a new course to the database. So course schema is an instance of that course schema object that we looked at before. And we're going to use load. Remember, we have load and we have dump. So load is the thing that's responsible for loading a serialized object from the wire into an in-memory structure that corresponds to the Python class. And what we're going to hand to that load object is just this JSON from the request. So the payload of the request that came in from the client is going to be this request.json. And we're going to just hand that raw object to the load method within this course schema. And what should come back out is going to be not only a Python class or an instance of that schema class, it's also, if it succeeds, it's going to be vetted by all of the constraints that we imposed upon it in that Marshmallow schema. So it's going to check to see that all the fields that are required are present, that the validation functions pass muster, that we didn't try to pass in a negative value where a positive one was required, and we didn't try to use an empty field for the name of the course and that kind of stuff. So all of the things that we want to ensure are true about this new inbound course are going to have been vetted by this Marshmallow course schema instance. So this is this is exactly the reason that we're using Marshmallow, or primary reason that we're using Marshmallow, is we want to make sure that we're verifying the inbound contents of all these requests, so that if a bad guy tries to access our API, that person is going to be thwarted when they try to put bogus data into the API. It's possible, of course, that we fail the validation, and the way that Marshmallow works is it's going to just raise an exception if that's the case. So we've wrapped this call to course schema load in a try except block. This is just the standard Python way of dealing with an exception that's thrown. So if this thing does throw an exception, we're going to catch it. And if it does throw, it's going to throw an object called that's of type validation error. We're going to capture that, and we're going to send back to the client a JSON version of the messages that are coming out of that error. And what happens here when Marshmallow does this verification, if it finds problems, it'll actually create a list of messages that indicate what's wrong with that message. Now, that may or may not be of use to display to the end user over on the client side. It may, but at the very least, we're going to give the client enough information to try to report to the user that something went haywire here. So we can say we're going to JSONify that object, so we can send that across the wire, and we're also going to set the response code to 422, which basically says you've got some bogus data in this request. Now, if everything verifies or validates successfully in this course schema load function, then of course we're not going to throw the error, so we'll just continue on down here. And we've got invalid course. We have gotten an internal version of this serialized data, but it's not yet an instance of the ORM's course class. So basically what we're doing next is calling the course constructor, and we're passing as values all of the fields from this valid course object. And this is the Python convention for sort of putting turning this object into a list of keyword value pairs, which is what these course constructors expect. And that's going to actually create the new course. And so this new course is going to be a SQL Alchemy object, but it's still just in memory. We got to be able to sort in the database. So again, using that DB session object that we talked about before, we're going to add this new course to that session. And that's going to basically say, okay, queue this up to be added to the database when we're ready to do that. And in this case, we're only going to add one thing at a time. But if you were trying to add a bunch of courses, or you were trying to do something more elaborate with a transaction, for example, you might add multiple things to the session at once. And then when everything is queued up to go, you finally call session.commit, and that will actually cause the contents of the pending database operations to be executed against the database itself. And by the time this thing returns, the new course, in this case, will have been made persistent in the database. We're also going to send the new course back to the client. For example, if we want to be able to share with the end user what the ID value is going to be for that newly created course, we can do that. So we, again, always JSONify this thing to send the results back. And we've got a status code as well. And 200, of course, is the generic OK status in HTTP. 201 is the successfully created something OK status. So we're giving a little bit more specific feedback by using the 201. So what we'll see, or what you'll see as you look through the code, is all of these different modules that correspond to the functionality of Corpus Christi have this same basic shape. They're going to have an init file that you're probably not going to have to worry about at all. They're going to have an API file that's going to have all of the endpoints. And for the most part, these functions in here are just single Python functions that respond to a specific route. There might be some additional helper functions that don't have decorators, like here add prereqs. It's a helper function that takes, etc. You can read through this, but this is just a function that's going to be reused in different places throughout this file probably, so we've abstracted out that particular capability. and put it right here in the API file because it's the only place that it's used. You're going to have the models file that will have the SQL Alchemy ORM file or ORM classes, as well as the Marshmallow schema validation classes. And the final thing that you'll see in these files or in these modules is going to be a file called test underscore something. So test underscore courses. And this is a collection of functions that are used by our testing tool to verify that all of the API endpoints in the courses module are working properly. I'm not going to talk about testing in this presentation, just to kind of keep it a little shorter, but I'll share that information in another recording.